Hi guys, I'm going to be doing a little demo with you today showing Newton's first law of motion in action. Newton's first law of motion is the law of inertia, which states that any object in motion wants to stay in motion and an object at rest wants to stay at rest unless acted on by a net external force. So we're demoing that today with two nearly identical eggs. We have a hard-boiled egg and we have a regular raw egg. The easiest way to tell the difference between these two eggs would be just to crack them open and find out what's inside of it. But there is another way that you can do that without actually cracking the shell of the egg. So if we have the two eggs, we're going to spin them both. One of the eggs, if you stop the shell of the egg will completely stop spinning. That one should be the hard-boiled egg. The other egg, the raw egg, when you spin the egg, one, it's going to have a little bit of a wobble to it because it has liquid on the inside. And two, because it's liquid on the inside, that liquid inside is going to continue spinning even when I stop that shell of the egg. So when I stop the egg and then I release my finger from the egg, it should restart that spinning motion again. So let's test it out and see which one is going to be the hard-boiled egg and which one is going to be the raw egg. Totally stopped moving. And the spinning restarted again. Let's try that again. I'm going to spin the egg. I'm going to stop the shell with my finger. It stops briefly, and the spinning motion continues. So that happens because the inside of this egg is liquid, and that liquid inside and that liquid yolk on the inside, even when I stopped spinning the shell of the egg, the inside continued to spin. So when I released my finger, released that pressure from the egg, it was able to restart that spinning motion again. The hard-boiled egg is a solid interior, so once the shell was stopped, the entire motion of the inside was also stopped, so that egg could no longer keep spinning. Stop spinning. Restarted the spinning. So this is a really easy lab for you to try out at home, and you can maybe teach your siblings or your parents about how to tell the difference without actually cracking them open. So this works kind of similarly in a small scale to what happens on the Earth. So the Earth, as it's orbiting, it has a wobble to its rotational motion. And that's because there are a lot of areas in the Earth that are a liquid. The oceans contribute to the wobble, the liquid outer core contributes to the wobble, and the partially molten asthenosphere contributes to the wobble. So because the Earth has so much liquid on it, and all that liquid has inertia as well, it contributes to the wobble of the Earth. The Earth completes a full wobble about every 18 or so years. We're actually right now studying Mars and studying the wobble of Mars. It wobbles a full wobble about every 2 years to try and figure out if the core of Mars or the outer core of Mars is actually a liquid or a solid. And that would give us a little bit more of a background into the actual structure of the planet and maybe the possible outcome of our planet. Who knows? So thank you. If you have eggs at home and you have nothing to do because we're kind of all stuck home right now, try this lab out and see how it works. And then you can have yourself a nice little snack afterwards with the hard-boiled egg. Don't eat the raw egg. Just eat the hard-boiled egg.